It's the middle of July. Outside, the heat is brutal, well over 100 degrees. Walk down almost any suburban street and listen. What do you hear? The constant, deafening roar of air conditioners. Electric meters spin like slot machines, straining an already overloaded grid while families watch their power bills climb higher and higher. But then you step into a very different house on that same street. Inside, it's 68 degrees, cool, crisp and fresh. There's no roaring fan, no dusty ductwork, and no giant metal compressor rusting in the backyard. And the cooling bill is exactly $0. How is that possible? It isn't futuristic technology. It's a shape. One carefully designed angle. A roof that breathes. Welcome back to The Roots Survived. Today, we're uncovering a quiet injustice that has been hiding in plain sight for nearly 70 years. We're going to explore how a house built around one calculated slope can cool itself indefinitely for $0, using nothing more than thermodynamics. We'll trace this idea back to builders who understood the principle 3,000 years ago, and we'll look at how a $300 billion industry quietly pushed breathing houses aside while keeping homeowners dependent on a paid subscription just to stay comfortable. And by the end of this video, I'll give you a complete blueprint, including a $200 weekend project you can begin this Friday, to make your existing home start breathing for free. Let's dive in. Part 1. The Machine of Angles. Why one slope beats AC. Let's begin with a physical truth you've experienced countless times. Walk upstairs on a hot afternoon. The upper floor is almost always hotter. Hot air is lighter than cool air, so it rises and gathers against the ceiling. In a conventional peaked roof house, that trapped heat can continue baking the living space long after the sun goes down. A single-slope house, often called a shed roof house, takes that basic law of physics and turns it into a self-powered cooling engine. Instead of two roof surfaces meeting at a central ridge, a single-slope house uses one continuous plane rising toward the sky. At the highest point of the tall wall, large operable vents are installed. Down low, on the opposite shaded side, the windows are positioned. As the afternoon sun warms the air inside the house, that hot air naturally rises along the sloped ceiling toward the highest point, where it escapes through the upper vents. As the hot air leaves, the pressure inside the house drops slightly. That lower pressure behaves like a silent pump, pulling fresh, cooler air from the shaded side through the lower windows to replace what escaped. The house literally inhales from below and exhales from above. And it does it for free. But there is another force that makes this angle even more powerful: the Venturi effect. When summer wind strikes the tall side of the house and moves over the upper edge of the roof, the airflow accelerates. That faster-moving air lowers the pressure above the high vents. The wind then helps pull even more hot air out of the building. The angle itself becomes the machine. Part 2. The Four Silent Giants. The Thermodynamic Network. If you're skeptical, that's understandable. Most of us have been taught that comfort is something a machine produces. But real comfort comes from balancing three basic conditions: deep shade that prevents radiant heat from entering, moving air that cools your skin, and a path that allows humidity to escape. The single-slope design does not depend on one device. Instead, it combines four independent thermodynamic forces, the four silent giants, into a network that continuously supports itself. We've already met the first two, the stack effect and Venturi suction. The third giant is radiant shading. Because a single-slope roof creates one long, uninterrupted plane, it can support extremely generous overhangs along the south and west sides of the house. During summer, when the sun is high and intense, those overhangs completely shade the glass, preventing direct solar heat from entering the home. During winter, when the sun travels lower across the sky, its rays can pass beneath the overhang and flood the interior with warmth. The fourth giant is thermal mass. A single-slope home commonly sits on a heavy concrete slab. That concrete acts like a thermal battery. During a hot day, The massive floor absorbs surrounding heat, functioning as a heat sink without rapidly increasing in temperature. Then at night, when outdoor temperatures fall, you open the vents and allow cool night air to move through the house, carrying the stored heat upward and out. By morning, the floor is cold again. Even on a still, humid afternoon when the wind disappears, the remaining forces continue doing the work. The house stays cooler because much of the heat was prevented from accumulating in the first place. Part 3. The 3,000-year ancestor. Proof from the cruelest deserts. None of this is a modern invention. It is inherited knowledge. Travel to the central Iranian desert, and you'll find the ancient city of Yazd, sitting in a basin where summer temperatures regularly climb beyond 110 degrees Fahrenheit. Yet people have lived there in relative comfort for more than 2,000 years. Their secret? Tall clay towers known as badgers, or wind catchers. These towers capture desert breezes higher above the ground and guide them downward through narrow shafts, increasing the speed of the moving air. That air can then pass across underground water channels known as qanats, delivering air into the buildings that may be as much as 18 degrees cooler than the street outside. The same kind of practical cooling intelligence appears elsewhere. In ancient Egypt, porous clay jars were used to help cool interior spaces. In the American South, traditional dog trot houses were built around open central breezeways that allowed air to move directly through the home. Then, in 1996, architect Mick Pierce demonstrated that the same principles could work on a massive modern scale. In Harare, Zimbabwe, he completed the Eastgate Center, a huge 9-story office and shopping complex. Air conditioning was intentionally left out of the original design. Instead, Pierce studied termite mounds. He recreated their ventilation principles using concrete and steel, with 48 large brick chimneys helping drive passive convection throughout the complex. The building used 90% less energy for cooling than comparable conventional buildings, while saving $3.5 million in upfront construction costs. If this worked for Persian builders, termite colonies, and an enormous modern commercial complex, why are we still constructing sealed boxes that depend on machines to keep people comfortable? Part 4. The Great Erasure. How we bought a subscription to cold why. Does all of this sound like a secret you're hearing for the first time? The answer is economics. In 1902, Willis Carrier developed mechanical air conditioning to solve a humidity problem inside a printing facility. Then, after World War II, the housing boom exploded. Developers suddenly needed to build millions of houses as quickly as possible. Traditional passive cooling strategies, heavy masonry walls, deep porches, and careful solar orientation required time and skilled labor. Mechanical cooling offered a shortcut. Builders no longer had to shape houses around natural airflow because a machine could compensate for almost any design. So they built cheaper, lighter boxes on slabs and allowed homeowners to keep paying the electric company indefinitely to make those houses livable. To reinforce that shift, the HVAC industry promoted mechanical cooling while presenting passive methods as old-fashioned or primitive. Within only a few decades, much of that older knowledge disappeared from textbooks, contractor training, licensing exams, and public memory. Follow the money. The global heating and cooling business is worth close to $300 billion every year. Nearly 90% of American homes use air conditioning. A central AC system is a mechanical machine constantly working against heat. It relies on chemical refrigerants, sensitive electronics, and high-pressure compressors. From the moment it begins operating, its components start wearing out, with many systems lasting roughly 12 to 15 years. And one of the industry's most profitable pieces is the recurring service agreement. But a shape has no moving parts. It cannot be patented, it cannot be metered, and no company can sell you the same shape again every 12 years. That missing stream of recurring profit is exactly why the shape had to disappear. Part 5. Locked out by law. The code and HOA trap. The second objection you'll hear is simple. It's illegal. And this is where things become frustrating, because they are almost right. But the issue isn't safety, it's regulatory capture. For nearly a century, building codes recognized natural ventilation, simply opening your windows, as a legitimate way to ventilate a home. Then, in 2012, the International Energy Conservation Code required new homes to be sealed much more tightly in order to conserve energy. But once a house is sealed, it can no longer breathe naturally. So, the International Residential Code added Section R303.4, requiring whole-house mechanical ventilation. Standard 62.2 defines that ventilation around a motorized fan. One rule forces the building envelope shut. The next rule requires you to buy a machine so the sealed building can breathe. In practice, the naturally breathing house was pushed aside and replaced by a mechanical box that provides ventilation for a fee. Then above the building code comes another gatekeeper, the Homeowners Association, or HOA. HOAs often require houses to follow a uniform, symmetrical suburban appearance. They may dictate minimum roof pitches and explicitly prohibit single-slope or shed roofs because they are considered inconsistent with neighborhood character. And those restrictions are not necessarily about structural safety. A single-slope SIP barn-dominium can be engineered to withstand wind loads approaching 200 miles per hour, winds capable of devastating standard homes. Yet the design can still be rejected because a committee decides that a slanted roof looks wrong. The result is a perfect cycle of dependency. The utility company sells you the cooling, the manufacturer sells you the equipment, and the lender sells you the interest on the 30-year mortgage. Part 6. The Climate Compass. Who wins and who pays the tax? Let's be clear. No building design is a magic solution for every climate. How much you gain depends heavily on where you live. If you're in the dry Southwest, Phoenix, Tucson, Las Vegas, or El Paso, you've landed in the thermodynamic jackpot. Those climates provide nearly perfect conditions, extremely dry air combined with large temperature drops overnight. A correctly oriented single-slope home or courtyard house can achieve an indoor temperature reduction of around 20 degrees without mechanical cooling, allowing the air conditioner to remain silent through much of the summer. But what if you live along the humid Gulf Coast, from Houston through New Orleans and all the way down to Miami? There, summer air can feel like a thick soup of moisture. A passive stack purge alone will not bring your cooling bill to zero because humid air prevents sweat from evaporating efficiently. Does that mean the idea is useless there? No. A large machine learning study published in 2025 showed that even in hot, humid climates, a compact, heavily shaded house, designed to breathe, can still significantly reduce cooling demand. You simply pair the passive design with a small dehumidifier or modest mini-split operating at a fraction of the usual power. The shape carries 80% of the load. The machine deals with the moisture. If you live in the freezing north, Minneapolis, Chicago, or Buffalo, the same single slope becomes a huge passive solar collector during winter. The low winter sun reaches deep beneath the roof overhang and warms the concrete floor, while that same overhang blocks the higher summer sun. One shape, two opposite seasons, and in mild regions like the Pacific Northwest, a breathing house can become a genuine survival system during extreme heat domes, helping keep the interior cool even when the electrical grid fails. Part 7. The Full Build Playbook. How to bypass the monopoly. If you're purchasing land or building a house from scratch, this is where you can capture the full benefit. You may be able to eliminate the need for a large central AC system entirely, saving thousands of dollars up front, while reducing energy bills for years. But if you want the design to work, you need to understand how to navigate the gatekeepers. Here is the playbook. First comes orientation. Before pouring even 1 yard of concrete, find a free windrose chart for your zip code. That chart shows the prevailing wind direction, which determines how the high side of your roof should be positioned. Second comes geometry. Build the house beneath one continuous sloping roof. On the tall wall facing the wind, install a row of high, operable clerestory windows. On the lower, Opposite shaded wall, position the inlet windows. Protect those windows with deep roof overhangs so direct summer sunlight never strikes the glass. Third comes thermal mass. Pour a thick concrete slab or install dense tile flooring. Keep that mass exposed to the interior air. Do not bury your thermal battery beneath thick carpeting. Fourth comes the paperwork. When you enter the local permitting office, your vocabulary becomes your shield. Do not describe the project as an off-grid breathing house. Instead, describe the high vents and central openings using terms such as an atrium, a light well, or a private open space amenity. Describe the solar chimney as a south-facing thermal mass wall. And to satisfy the Energy Code's mechanical ventilation requirement, include a small, inexpensive heat recovery ventilator, an HRV or ERV. That device satisfies the mechanical fan requirement for a few $100s, while the passive chimney and the geometry of the house perform 95% of the actual work. Part 8. The $200 Weekend Retrofit. Force your current home to breathe. But what if you already own a conventional suburban house? Or what if you're renting? You don't need to tear down walls to capture 80% of the benefits of this system. This weekend, you can build a smaller but highly functional version of this ancient cooling machine for less than $200. Here is your Friday to Sunday blueprint. Friday is the diagnosis. Buy a basic $15 digital thermometer. Late in the afternoon, walk through your house and start measuring temperatures. Check the air near the floor, then go upstairs and measure again near the ceiling. You'll probably discover a trapped layer of superheated air that can be 10 to 15 degrees hotter than the rest of the room. That hot pocket is your enemy, but it is also your opportunity. Saturday is the build. Now we're going to give that trapped hot air somewhere to escape, while creating an entrance for cooler air. Start with the exhaust engine. Buy a standard $20 box fan and place it in the high window. But here is the important part. Do not aim the fan so it blows air into the room. Turn it around. Make it blow air out of the house. Seal the gaps around the fan with an inexpensive foam strip or even a towel so the fan cannot immediately pull back the same air it just pushed outside. That box fan has now become an active exhaust engine. Next, open a low window on the cooler, shaded north side of the house by about 4 to 6 inches. You've now created a complete, continuous convective loop. Finally, buy an inexpensive bamboo roll-up screen or outdoor shade sail and place it outside your sunniest windows. Block the heat before it ever enters the house. Sunday is the commission. At night, open the low window and switch on your high exhaust fan. Allow the cool nighttime air to flow through the house, pulling the day's stored heat out of your drywall, tile, furniture, and interior surfaces. Then, right around dawn, before direct sunlight begins heating the house again, close everything. Seal the cool air inside. You've just banked the night's cold and officially taken back control. Imagine the middle of the next record-breaking heat wave. Millions of compressors are screaming across the city. The electrical grid bends under the demand, and suddenly the power goes out. Within hours, those tightly sealed houses begin turning into stifling ovens. But your house remains quiet, cooler, and comfortable. Fresh air moves inward through the low-shaded windows, while hot air rises and escapes above, just as it has since the builders of Yazd laid their first clay bricks 25 centuries ago. You are no longer paying a subscription just to stay alive. You have reclaimed something that was quietly zoned out of the modern neighborhood, a shape. The oldest, cheapest, and most honest cooling system on Earth. The physics has always been here. What you choose to build with it is entirely up to you. If a home that gives something back instead of sending you another bill sounds like the future you want, hit the subscribe button. Share this video with someone who is tired of watching their electric bill climb, and join the ranch revolution. And tell me in the comments below, what is the highest single-month summer electric bill you have ever received? Just leave the dollar amount. Let everyone watching see what the machine has been charging us to accomplish what a roof can do for free. Thank you for watching. And remember, True independence begins when you build it yourself. See you in the next archive.